Oh, good Saturday afternoon, folks. This is the Land Tamer stream. We're going to do probably a quick lab. We're getting into the OSPF route filtering section. So I want to go over just a couple things before we start the lab. One, this is going to be, I didn't tweet this out, it's going to be a brief lab. It's Saturday, a lot of social stuff, family stuff going on. But I did squeeze in some time to prepare for this lab. There's a good bit of homework it's kind of needed to do. This is really new for me, so I need videos, watched several of those, got some of those in, and did some reading. We're going to go over the configuration guides section because there's some important documents I had to review to go over filtering in OSPF v2. So just a couple thoughts about the stream today. Again, as I said, it's going to be brief. There's some requests to, one of my faithful viewers, Demetrios, talked about Wireshark. I'd like to see that more on the stream. Yes, we are going to do Wireshark. I need to do Wireshark. It's going to be critical for the troubleshooting section of the lab, I know, and just really understanding protocols in general. What I've decided to do is, since there's a new viral version coming out, I think next week. I don't know what day. But in lieu of the fact that that's going to require a complete teardown and reinstall of viral, I'm going to wait for that because I don't want to configure something or have to tweak anything and then redo it. But I did do some study on that today, or looked up some information on what is required. I've not looked at the documentation yet for the new version of viral, so I don't know if that's changed at all. Maybe it hasn't, but we're going to have to reinstall anyway. I'm going to stream that, by the way. We're going to stream the viral upgrade, for lack of a better term. And then I'm also going to stream configuring Wireshark in viral. So we'll do that as a video. We'll do that all here on the stream. So any gotchas, you'll be able to see those. And hopefully it'll be just real easy based on what I'm reading. So those are some thoughts on that. I appreciate the feedback, though, and we're definitely going to start incorporating that. It would have been useful yesterday when we're looking for the routing bit, which, man, I hope they fix that too in this version of viral and whatever code we're going to be running. But anyway, in preparation for route filtering and OSPF, I had to do a lot of study because it's a lot different than what I'm used to in the IGRP, RIP, etc. And that has to do with, of course, the nature of the distributed database of OSPF and LSA types, and just the fact, just the design of the protocol. You can't just arbitrarily at any point try to filter routes because, there is some very basic route filtering you can do, even after calculating SPT, or SPF, or whatever the case may be. You can still filter what goes into your local RIB, but that can be dangerous because, again, the distributed nature of the link data is going to mean that let's say you are between two routers in OSPF, and you filter in your local routing table, you're still going to advertise those routes. Potentially to another neighbor. And now every neighbor past him in that area is going to lose reachability because they're transiting you as a router and you filtered it out of your local RIB. So you create a black hole. So there are a lot of rules about filtering in OSPF. And for my own knowledge, I may actually do a flashcard on that just to kind of summarize what those are. But a lot of it boils down to, at the ABR or the ASBR is where you're going to want to do any type of filtering. So, and there are rules about which types you can filter and which you can't in different scenarios. So I hope these labs are going to cover a lot of those. The video was kind of brief. The INE material video was kind of brief on it. There's a good bit of reading, though, and let me just kind of review what those were. If some of you subscribed to me on Twitter or Instagram, you saw that I was doing a lot of this today while at the shopping mall. But really good reading. We'll see how much I retained based on the study environment I was in. But this is really important. This one here, ABR Type 3 LSA filtering. And this essentially covers, again, it is brief, but there's a lot of good information under, let's see, this is basic configuration. There was some explanation here, though. well, maybe this, feature information. No, not there. Another one of these that was good, which is a really good one. Forwarding address suppression. Okay, inbound route filtering using route maps. This is good because this uses a distribute list feature, which we're used to with the EIGRP and RIP, but the difference is, again, this is only, a lot of this is really influencing, it has nothing to do with LSAs, but a lot to do, if I have this, well, you can use some of the tags. So again, this is information. We're not going to be doing a lab on this today, at least I don't think. Okay, the ASBR, yeah. That's what I was thinking, not at the ABR. That's where this is useful. There is some information. What was another one that was key? This one, OSPF mechanism to exclude connected IP prefixes. And this, I believe, is the prefix suppression. That can be a little drastic. There are certain use cases for that. I don't know if we're going to have a lab on that. I hope we do, because I can see where that was going to be useful when we start doing MPLS, when OSPF is used as a transit area. And then this is where it talks about the RIB and OSPF and how you have a local RIB that's assigned to an OSPF process. And again, this is a feature of filtering or adjusting the criteria, which can come into play when you have multiple RIBs or multiple OSPF processes. So if you're running OSPF router 1, OSPF router 2, for example, 2 processes, and you've got some matching routes, how do you control which inserts, which process, when there are conflicts, which inserts routes locally into the RIB, routing information base, the global routing information base? Well, you can configure the localized RIB for each of those processes, and you can set preferences there. Good read. There's some use cases there, examples as well. Highly recommend reading that if you have not and are working on OSPF right now. Even if you're not, it's a good read. There's one more that I think I'm missing. Inbound for address suppression. Maybe it did not get marked as read. I've found that happens sometimes. Even though I'm reading with Safari on my phone, iPhone, and Safari on my Mac, usually this will be in sync. Look at this again. Did I miss something here? Well, it does describe, this is the use of the filter list. And this is when you're at the ABR. Again, it mentions here ABR because, as we know, the ABR, and this is good for me to talk about this. So let's say we have area 0 and we have an ABR here. In fact, let's use today's lab because we'll just jump right into this because this is the feature we're going to be using. My expectation is we're using an area filter list feature because look at the requirements. The title lab is OSPF LSA3 filters. On router 5, which is an ABR between area 0 and 3, we want to filter such that area 0 routers do not have information or reachability on the VLAN 108 subnet and router 10's loopback 0. So that is here and this loopback. So what's going to happen? These will be router types, LSA types 1, router LSAs, and 2, network LSAs. It's R5's job, of course, to generate or convert 1 and 2s to 3s, right, to flood into area 0. So there are certain rules about this type of conversion, and when you can filter and when you cannot. If there are LSA 1s and 2s that R5 knows about from the database, then yes, it can certainly not only is it allowed to summarize those as an ABR in area 0, but it can filter. And it can do that in both directions. And that's what we're going to do in this particular lab. There are some things that it cannot do, right? Even though it's an ABR between these areas, there's certain instances where, let's say a summary route comes in from area 1. Let's say an ABR of router 4 knows about a number of router type 1s and or LSAs 1 and 2s and summarizes them into, sends multiple LSA3s into area 0. Router 5 cannot then take those summary routes 3 to 3 and re-summarize them. It cannot summarize 3 to 3, right? So, of course, these are going into different areas. But that is one of the rules there. And one thing you can always look at is when you're looking at the LSA types is who is the advertising router, and essentially that's going to tell you. There are a lot of other rules I'm not going to cover because they don't apply in this particular lab, and a lot of them apply to type 7s and 5s, etc. But a lot of clue. One thing I learned from the video today is if you look at the LSA, and if you look at the advertising router, essentially that is going to be the router that you want to use to select to do any filtering and or summarization. In this case, though, we're not doing summarization, although summarization is one method of route filtering in OSPF. We are using the ABR and the conversion. Hey, how's it going, Demetrius? Good to see you too, man. Yeah, it is an early day for me. I know you're probably nighttime there. Got an event coming up, so it's going to be brief today. But I did get some studying today, and hopefully do a bunch of labbing tomorrow if all goes well. But yeah, great to have you as always, my friend. So yeah, we're going to do here some LSA filtering as we described, and it's real important, as from what I've read, that when you use the filter list, that you understand well the from and to, right, and where you apply the filter, because you can apply the filter in or you can apply it out, inbound or outbound, but just be sure that it's applied to the correct area, in or out, as a conversion has taken place. So here we are. What we want to do again on router 5 is our ABR. Area 0 routers do not have information on. So this is going to be a filter from area 3 to 0. And we're going to have a filter list, and we're going to use an IP prefix list because we only want to filter certain prefixes and allow all other prefixes, right? We're going to do a deny and then a permit. Same with this requirement that area 3 routers will not have information on just a single prefix, which is router 1's loopback 0. And again, here's the key. I love these little clues. These are weighty clues here, right? These words are not here for no reason. And that's what you often see in the lab, right? In Cisco exams. Sometimes they'll put these little clues to make you think they're really significant when they don't mean anything. And sometimes they put them here because if you ignore them, you're going to miss. You're not going to get any credit. But here it's saying, I think this is important. So what this tells me is I want to do a deny and then a permit, right? And we do not want to affect any new areas that were added. So let's say on router 5, let me see if I can do my cool zoom thing here. Let me quit because it went into another screen instead of the screen. I guess when you launch it, it uses the screen you're on. But there's a magnifying glass here that I kind of like. So yeah, when you so this sounds important, right? Because What if we were to add a new area to router 5? So let's say, like right now I'm in two areas, the yellow and the blue, or the aqua blue, which is area 0, and this one, which is area 3. Let's say if I order a new circuit and I get a new, or whatever, I have a new router, expansion in the office, a new closet, and we decide to set up a new area. What I want to be sure about is that from here on out, there's a couple ways I could do this filtering, right? I could do it inbound this way or outbound that way into 3. But I want to be careful in that I'm only affecting area 3 in this particular configuration. And in this requirement, we want to filter router 1's loopback coming into area 3. So my first tendency was to say I'm going to apply this configuration to area 0 in. But if I do that, that's going to affect any areas that router 5 is connected to other than area 0. So that's an important clue. It sounds like what I need to do is area 3 in, and I need to do an area 3 out. My initial tendency was we're going to do 0 in. Typically, like, what do they always say when you are doing security, right? When you're using access lists and you're denying traffic, you try to get as closest to the source, right? Filter as closest to the source as possible. Well, we can't think that way here. We have to think about the overall routing topology. This is not security specifically, but my tendency is always do that. When I'm going to apply some sort of filtering of traffic, whether that be routing protocol traffic or routed traffic, is, apply it coming in when you can. But if we were to do that here, again, we would not meet the requirements. So we've kind of belabored that point. Let's go ahead and think about the configuration. And I will fire up the terminals here. And we'll put the map back where he goes. So again, we're just going to be working out of router 5 because router 5 is our ABR between areas. And let's just verify now that we have that we already have the information to filter it out. Oh, let's just do show IP route. Router 1's loopback is 150.0.1.1. Or is it 1? Yeah. Yep. Okay, so we have that route. And the VLAN, let's go ahead and write this out because we're going to have to do a prefix list, right? 150.1.1.1. And 0.0.0.0 is going to be our, actually no, prefix list. Not an access list. We're going to use a prefix list. And then that's this traffic. And then our other traffic is here, VLAN 108. We can get all this information from router 10, right? I should know this by now, but my brain selectively chooses not to memorize what it absolutely does not think it needs to memorize. So show IP interface brief. This is probably going to be, 108.10. So this is going to be, I know that this is /24. So our other traffic is 155.1.108.0. And router 10's loopback 150.1.10.10. Okay. I'm going to put these in here. Well, actually, no, because we're not. Yep. We're not doing any kind of range. All right, so those are the routes that we want to filter. And again, what we want to filter, let's look at our first requirement. Area 0 routers do not have information on. So that's going to be area 3 out. And it's going to be these two prefixes. This is going to be area 3 in, this prefix, right? Everyone's nodding their heads. Okay, great, awesome. Let's look at our configuration guide, because it's the first time I'm using this. It looks really simple. Router OSPF process ID, area number, filter list, prefix name, in or out. So I'm just going to copy this here. And let's go over to our router and let's do this, right? Actually, let's do our prefix list first. IP prefix list. And let's give it a clever name. Area 3 in. IP prefixes, and we're going to say sequence 5 or 10 deny 150.1.1.1 205 205 205 205. Deny, yeah, /32. Okay, and then I think after that we need to do a sequence 20 permit 0.0.0.0/0. So that is going to be a range of prefixes, right? Any less than or equal to 32. Okay, so then we want to do IP prefix list area 3 out sequence 10 deny 155.1.108.0/24. IP prefix list area 3 out sequence 20 deny 50.1.10.10. And then IP prefix list permit all balls. Let's see if I got my prefix lists right this time. I had to study up on that a little bit more. I was getting myself confused when I was in EIGRP, but let's see if I got these right. So now we can do a router configuration, and we're going to say area 3 filter list prefix and then the name in. Yeah. Area 3 filter list prefix area 3 out. Okay. Configuration is done. So what we can do for verification, show IP OSPF. And we should be able to verify here that we have filtering applied in area 3. And we do. Area filter, area 3 in, area filter, area 3 out. Number of LSA 26. There's actually a lot of good stuff in here in this command that I've been ignoring earlier. But as I was reading the configuration guides today, this command becomes really important. There's, maximum metric. Number of areas in this router is 2 normal. I'd forgotten all about this. This is another way to verify what area types you have. And then we have the areas here, the types, number of interfaces. And this is cool too. SPF algorithm last executed and number of times. So we can actually watch that increment too and make a change. If you have ranges applied, flood list length, of course your authentication. There's some other things that if you turn on, for example, if you turn on prefix suppression, you'll see that here too. Okay, so we verified that that is applied. We also need to verify our database now in area 3. So let's take a look at that. And what we're looking for is summary. Let's just see a very specific command, right? We should see a summary for 150.1.1.1. We do not have it. We do have 2.2 though. So it looks, at least at this stage, that our filter list has worked properly. Let's show IP route. Okay, this is going to be here because he is in area 0. But if we go to router 10, not in the table. Awesome. We could get really cute too, and if we wanted to, and create a new area here and see if it lands in that database. Can we do that with just a loopback? I think we can. Let's try it. We got a little time right now. We're not going to do another lab, so let's get crazy. Interface L100, 150.1. No, let's do 160.1.5.5. I didn't see the message that it was up. Oh, did I do just, okay. I'm being silly now. I created an interface L100. Did I? Let's see. What did I do? I just did something that caused the router to like console connection to reset. And I can't even see. Oh, no, I did L0. Okay. No wonder it went nuts. 150. Watch it do it again. Yeah, I really like broke it that time. I thought I typed interface L100. Yeah. Oh, there we go. That's what I was expecting. I could have swore, and I'll be able to look back in the logs. Interface L. Oh, okay. See, look at that. This is a very, yes, this is a very innocent mistake that in a real world lab I would not want to make. Can cause lots of pain. Exactly. Thank you, Demetrios. I caught that later when I went back. I was like, oh, okay. I left out the 1 and really, okay. Well, fortunately, we caught it early enough, right? Interface L100. See, I knew something was wrong when I did not see this pop up. Because you always get that right away, right? Like, something's wrong. Well, that was fun. Okay, now we want to do, let's see, area show, do, I'm pretty sure this is configured. Areas are configured at the, yeah, they are at the router level. So let's do interface or router OSPF1, network 160.1.5.5. I actually have to use wildcards here, yeah. Wildcards go in your network statements, both in OSPF and EIGRP, right? And this is going to be area, we're going to create a new area 10. So now we should see, yeah, 10, one loop back. Okay, cool. So if I do show IP OSPF database, in area 10, I should still have a summary route for, and I do, look at that. So good, we have met the requirements and we've proven it because we're not filtering router 1's loopback into area 3. Let's do this for fun. Ping 150.1.1.1 source L100. Yep. Good deal. We knew we did it right, but we just wanted to have fun and check, right? So now let's check the other way, and that is area 3 out. Let's see if I did my prefixes correctly. Is there another way to verify on router 5 what I'm flooding out into area 0 besides show IP OSPF database? Show IP. Okay, it only shows me the entries there, unlike a route map, which will show you kind of a counter, right? So the only real way to verify, I guess, let's go over here to area 0, another router in area 0, and show IP OSPF database. And what we should not see is a summary. Now router 4 is, yeah, we should not see a summary for this /24 155.1. We do not. And we should not see a summary for router 10's loopback, and we didn't. Okay, that looks like, and look at this. This says, okay, we don't. Yep, we see router 9's. Well, 9's on the other side of the network, but we see router 8's. So it looks like we did that correctly. Let's look in the routing table. Yep, it's not there. And let's just do show IP route, just to be double, triple sure. 150.1.10.10. Yep. No reachability. Okay. So that was a pretty simple lab. It was not yesterday. In fact, yesterday I did not know how to do this. But again, I had to read these guides. Let me look at see just what the next lab is. We're rolling pretty good here. Let me check my key and make sure that that was correct. And it is, yeah. And my prefix lists worked. So I'm feeling pretty good about that. All right, next lab. Let's just see. Forwarding address suppression. We can probably knock this out because I already know what we're supposed to do here. So let's just. It is 5:15. Let me think. I have to leave. Yeah, I probably need to wrap it up here. I'll take care of this one tomorrow. And we're going to do there's some default routing. We've done a little bit of that. There's some conditional default routing tomorrow. Reliable conditional default routing. Reliable, read into that. We're going to use IPSLA tracking. And then filtering with distribute lists. That should be interesting. Summarization and discard routes. Okay, a lot more filtering. Filtering with route maps. External prefix filtering. We're going to do it at the ASBR level. And then filtering database. So a lot of filtering. We're going to dig in this tomorrow. Demetrius, good to see you, my friend. I'll be labbing hopefully throughout the day tomorrow until Twin Peaks comes on, of course. Well, you guys, hope you have a good rest of the weekend, and we will see you soon.